So this is a binomial distribution problem, and we can jump right in with getting a bearing on the binomial distribution equation, which in this case is n choose r, NCR, and then we have our probability of success to the amount that we have chosen. In this case, we do r. And then we have the probability of non-success, q, to the power of n minus r. Now, this may look like a lot at first, but in context, it makes a lot more sense. So in this case, we have 10 employed adults are randomly selected. And we want to find the probability that exactly 3 of them believe would be easy to find another job. And we are given our probability outcome of 59% for success rate. So what we do is set up our NCR. So out of a population sample of 10, we choose 3 people. And this is a more complex statistical equation, but we can just put it in our calculator, 10C3, and it will give us the right answer. And then multiply that by our probability of success, 0.59, to the power of how many are chosen. So that means 3 get chosen. And then our probability of non-success is just 1 minus this. So that becomes 0.41. So these both have to add to 1. And this, we have to do the probability of to the 7th power. So when we do that calculation, we will get 0.047999. So this means that there is a 4.799% chance that out of a population of 10, if 3 get chosen, then exactly 3 of them will have 59. You get the gist of it. So on to the next one. We crank things up a notch. We want to find the probability that more than 2 of them believe that it would be easy to find another job. So one way to do this would be do this calculation for starting at 2, 10 choose 2, then do 10 choose 3, then do 10 choose 4, then choose 5, but that will get very tiring very quickly. Another way to do it is approach it from the back end and do it from the least amount of work that we need to do. So we first want to do the calculation just to divide these up of 0 being chosen out of 10. Then we do the calculation for 1 being chosen out of 10, and we do the probability of 2 being chosen out of 10. And then from that, we do the same thing above for each of these, with the only thing changing being our exponents. So for this one, we will do 0.59 to the 0th power, and then we will multiply that by 0.41 to the 10th power. Okay, and then we will get a value for that. And then likewise, we do 1 and 9, and then we will do 2 and 8, all for the same probabilities of success that we see here. So we will get the values for those and add them all together. And in total, those will be the probability that we will get below 2 or below non-successes. So subtract that from 1, subtract this answer from 1, and then, subtract that answer from 1, and then that will give us our correct answer. We just saved ourselves all that work of having to run through it all. So finally, going through the methodology of the third question, I only have a little bit of time left. Would it be unusual if all of them believed that it would be easy to find another job? So in that case, we would do 10 and then choose 10, and then all of them having the probability of success. So 5.9 to the 10. And then our times our second one will be 0.41 to the 0th power. So then this just turns into 1. So this will be 0.59 times 0.59 10 times, and you'll get an extremely small number with many zeros. And then in that case, it will be an unusual circumstance for all 3. Well, everyone to say no.